Hello, dear students. Once again, I'd like to invite you to this series of mathematics problem solving. Last time I taught you on a standard notation or standard form of a mathematical number. So today I'm going to proceed with the definition of logarithm. Now, consider you have this expression of in a multiplication of number 2, maybe you have 2 times 2 times 2 times 2 times 2 times 2. Okay, this one we get now I need to write the number into exponent. This one will be equal to 2 power 1 2 3 4 5 6. Then this one is 2 power 6, which is actually 2 power 6 obvious is equal to this is equal to 64. Now from this expression 2 power 6 is equal to 64. Now I need to express it into in logarithmic form. Okay, now how can we write it into logarithmic form? Logarithmic form says exponent of a power always is equal to logarithm of a number given. Okay, logarithm of number given with the base of power of that number. Okay, now here is base. Now from this expression, what is an exponent of this number? Okay, of this expression. Now from the above, from 2 power 6 is equal to 64. Okay, now exponent of this number is equal to 6. Okay, this one 6, and the base is 2. Okay, and our number our number is 64. Now on converting this expression 2 power 6 is equal to 64 and writing it to logarithmic form, now it can be written as exponent, which is 6, is equal to logarithm of number, which is 64, then the base is 2. This is how we can define an exponential expression into logarithmic expression. So the general formula is exponent is equal to logarithm of a number with a base of a power. Okay, this is the general formula you're going to use throughout. Okay, now example number 1. Assume you have given an exponent expression, and you have told to write it into logarithmic form. Now example number 1. Okay, example number 1. Now assume you have given write 5 power negative 3 to logarithmic form. Okay, write this one into logarithmic form. Now solution. Remember, exponent always is equal to logarithm of a number and base. Okay, logarithm of number to base. Okay, now from this expression, now what is an exponent? Exponent is equal to negative 3. Our number is equal to 5 power negative 3, which is equal to 1 over 5 power 3. Please, if you have forgotten or you are not understanding what I'm doing here, please review my previous sessions. maybe by reminding you, any number, for example, a power negative number, any, this one is equal to 1 over a positive power. Okay, this is just a simple definition of what I'm doing here. So if you have not yet understood what I'm doing there, please refer my previous sessions on laws of exponent. Now from this one 1 over 5 power 3 will give us 1 over 5 power 3 means 5 times 5 times 5 now is equal to 1 and 5, and our base is 5. Okay, our base is 5. Now by writing a logarithmic form will be equal to negative 3, which is an exponent, is equal to logarithm of 1 over 125 base 5. This is the solution of the answer, and sometimes also can be given this question. Right, example number 2. Let's call it example number 2. Now write 8 to logarithmic form. Simple like that. Now write this one into logarithmic form. Then how are we going to do it? Now solution, just follow the steps I have already shown you how to do this. Okay, now we know our formula. From our formula, exponent is equal to logarithm of a number then base. Now express this one, express 8 into form of base and exponent. Now 8 is equal to 2 times 2 times 2, which is equal to 2 power 3. Now from this expression, now I can say 2 power 3 is equal to 8. Now write it into logarithmic form. Exponent, from there, exponent is 3, base is 2, and a number is 8. Now exponent will be equal to logarithm of number, which is 8, base 2. Okay, this is how we can write 8 into logarithmic form. Just remember the formula, which say logarithm of a number to base, which is the general formula I'm going to use on solving most of logarithmic expressions. So it's a basic formula for you to understand where we're going now. Now, example number 3. Now you can be now given a logarithmic number, and you can be now told to write it into exponential form. Now write logarithm of 327 to exponent. Write it to exponent. Now solution. Now this one can be written as, remember the formula says exponent is equal to logarithm of 3 and 27 number. Okay, now sorry, my intention was to write the formula. Don't know why I've written that, but let me repeat it. Now this one is n in base. Okay, now from there you can see our number, we don't have an exponent because we need to express our exponent from the number. Okay, so we get an exponent from the number given. Now our number is 27. Okay, and our base is 3. What is an exponent? Okay, now from here I can say let an exponent be is equal to x, because we don't know the exponent. Okay, now this one can be written now as Remember, now this one can be written as 3 power exponent, okay, 3 power exponent, this one is equal to number. Maybe like this way, formula. The formula of obtaining obtaining an exponent from the logarithm says base power exponent is always equal to number. Now what is our base? Our base is 3 and the exponent is x is equal to number, which is 27. Okay, this is the formula. So we should use this formula to obtain the an exponent from the logarithmic expression. Now this one now can be written as 3 power x. This one is equal to 3 power 3. Of course, 27 is equal to 3 power 3. Now, as you can see here, now our bases are the same. They have the common bases. Now, x will be equal to, from this one, x is equal to 3, which is the exponent is equal to 3. Now, from this one now, I can say, conclusively, now 3 power exponent, which is 3, is equal to 27. Okay. Now, from logarithm form, this one is equal to this one. Okay. Another question, number C. Okay. Another example. Let me give you another example of converting a logarithmic form to an exponential form. Okay, now example number 4. Now should we have example number 4, and you have given logarithm of 4. A logarithm of 2 base 4 is equal to a half. Okay, now write this one to exponential form. Okay, now from there I can say can now summarize this. The data or the information I have from the expression. Now exponent, we know the exponent is equal to logarithm of number and base. Now exponent here from this expression, now exponent is a half. Okay, and the base is 4 and the number is 2. Now from this one I can say exponential form. Now exponential form of this one is always expressed with the formula of, which says base power exponent is always equal to number. Okay, now base is 4, power exponent, which is a half, is equal to number. Now our number is 2. So this is how we can write a logarithmic form into an exponential format. Now let me give you another example. Write 0.1 into logarithmic form. Now I need to mix up. Okay, so if you make the question like this, okay, it's example number 5. Okay, my dear student, I'm trying to give you enough examples so to make you strong, especially if you meet with more tough questions. So I try to give you different kinds of questions and examples, and I hope if you have a question like this in hand, then you can be able to push it. Now, assume now you have given write 0.1 to logarithmic form. And I'm sure that you do remember the formula. Okay, so we should use the formula to solve this question. Now solution, we have 0.1. Now we have to write the logarithmic form. We know our formula: exponent is equal to logarithm of a number to base. Okay, now this is how we can write the number from the exponential form to logarithmic form. Now this one number, now write 0.1 to exponential form. Okay, now should remember now that 0.1 is equal to 1 over 10, because 1 divided by 10 you get 0.1. Okay, now this one can be written also is equal to 10 power negative 1. Okay, now from this expression I can say our exponent now is equal to negative 1. Our number we have already given is 0.1, and our base is 10. Now I can now write the logarithmic form of this exponential form, which is equal to exponent is equal to negative 1, which is equal to logarithm of number which is 0.1, and the base 10. This is how you can find the solution of that question. Now I am going to give you another example. Sometimes can be given a logarithmic expression and told you to find the value of that letter. Example number 60. Now assume you have this one. Find the value of x. Find x from logarithm of x base 8, which is equal to 2. Now find the value of x. Now solution. Now remember the formula says expression e is equal to logarithm of number and base. Okay, now from this one, now I can say exponent of a number, we don't know the exponent of a number, but we have base, which is 8. Sorry, we have one exponent here. Already we have one exponent, sorry. Okay, we have the exponent, which is 2. Exponent is 2 according to the formula, and the base is 8, and the number is x. Okay, now write this one into exponential form. Exponential form now the formula of writing exponential form from logarithmic form is base times power exponent. This one is equal to base power exponent. This one is always equal to number. Now from this one, our base is 8 and our exponent is 2, which is equal to number x. Okay, now from this expression I can say 64 is equal to x. Now conclusively I can say now the value of x is equal to 64. Now the value of x is equal to 64, which is the answer. Now let me give you a last example, and then I hope you will be able to work with the other questions. Let me give you another example here. Now assume you have given this question. Example number 6. This series mathematics problem solving. That's why I'm trying on my ability to give you more examples and more questions. So I'll be giving you more tricks, more tricky questions, so that you can be able also to develop your ability, especially when you meet these kind of questions. Okay, now assume now you have this question: logarithm of, I should write like this one, logarithm of 1 over 1024, okay, with base 2, Now this one is equal to x. Now find x. Find x. Find the value of x. Now solution. We know our formula says e logarithm exponent is equal to logarithm of a number to base. Okay. Now what is our exponent from this expression? Now we need to express this number into exponent. Okay. Now as I told you, we can express, or we can obtain the exponent of a number from the number given. Now the number is 1 over 24. Okay. Now 1 over 10 24. This one is equal to 1 over 10 power, I don't know, power 6, 7, 8. This is power 8. Let me say 10 power 6 is 128. No, 10 power 6 is 64. Power 7 is 128. Power 8 256. Power 9 5 12. 10. Okay, it is 10 power 10. This is 2 power 10. Okay, sorry, it's 2 power 10, which is equal to power negative 10. Okay, now from there I can see now an exponent of that power is negative 10 with the base is equal to 2. Okay, yes. Okay, the number already I have is 1 over okay, it's 1 over 10 24. Now remember, on writing the general formula of obtaining the expression from the logarithmic form, this one is always equal to, say, now base or exponent is always equal to, sorry, no, this equal sign should be below, okay, on the same level as b. Now b exponent is equal to number. Okay, now our b exponent now is equal to, our b is 2 and exponent is negative 10 is equal to number. Our number is okay, our number is 1 over 1024. I think like you have overlooked. Okay, from here, before I've solved, our exponent was x. Okay, here our exponent was x, because our formula, according, if you need to compare with the formula, exponent which is x, now x is 24. I mean is equal to 10. Now if now can refer there, you can see, now I can say exponent is negative 10. It's called negative 10, which is x is equal to negative 10, if you can compare there with according to an expression. Okay, because logarithm of base 2, 1 of 24 is equal to x. Okay, and this one is always an exponent which is base is 2, and then this one is negative 2 is an exponent which we are looking for. Now I don't know whether I should give you another example, but I think I should end there. But before I've ended there, I think I have something to add. I think I should give you another 8th example. Okay, I think this example is important for you. Okay, now example number 8. Now assume you have given, now the question is find the values of each of the following. Find the value. Now find the value of this one. Find the value of, now assume you have given a b logarithm of logarithm of and what am I trying to do? Okay, logarithm of base 10 and the 1. Okay, something like that. No, I think I've made a mistake here. Now this one is logarithm of 6 to base 6. Find the value. Find the value. Now solution, I can say into exponential form, this one is equal to e logarithm of number to base. Now from this one, what is our exponent? We don't have an exponent, and this is exactly what you are looking for. You are looking for an exponent. Now exponent is what exactly we are looking for, and we have a base of 6, and we have a number of 6. Okay, now we know always a base power exponent is always equal to a number. Okay, now our base is 6. Power exponent, which we don't know and we are looking for, is equal to number which is 6. Okay, now since we have a base of 6, okay, with the which is common to both sides, now which number should I have to put here? Okay, now if you put of course any number, for example any number without an exponent is power 1 by default. For example, if I write b, this one is always equal to b power 1. Or if I write 7, this one is equal to 7 power 1. Or if I write 9, this is 9 power 1 by default. So for there, now I can also say that 6 power e is also equal to 6 power 1. Now since we have the common basis, then exponent is equal to 1. Okay, now from this expression, the value of logarithm of 6 is 6 base 6 is equal to positive 1. That is the answer of the expression of logarithm of 6 to base 6. Now for today, I'd like to end there. I'd like to invite you on to the next session, where I'm going to finish up with logarithmic law of logarithm. Now for today, I'd like to end there, but in case of any problem or any question, please write me to my email at jprogramming@gmail.com, jprogramming@gmail.com. Then I can share with you the solution of the problem. Thank you very much. See you once again. Bye.